All right, let's go ahead and graph these two inequalities. First, we have this one. X is greater than 2. Now, first up, we'll see that it does not have an equal sign to it. So we're going to have a dashed line right here. And let's see if we can do that. We'll find where x equals 2, right? Remember, we're looking for the line, not the shading part of this. So on the x-axis, I would find 2. And again, I can put a point right there. And every point on this line right here is going to have an x value that's 2. Notice this equation does not have any dependence on y. So you could put points all throughout here if you like. It doesn't really matter if it's fractional or decimal, negative or positive. As long as you get that straight line right there, then you're in good shape. Now, what I want is a dashed line, right? So the way that I would do this, at least with technology, is usually I'll draw the line, and that really isn't too bad for me. And then, of course, I can just use a eraser to make those dashed, if that's what you want to do. Some students just do like to make it a dotted line, which if that's you, that's fine too. So you may end up with something that may look, a little bit like this. Now this is not very straight, and actually that's not too bad for me, but again, you want to communicate some way that the points on this line are going to make this false, because everywhere x is 2 and 2 is not actually greater than 2. Now for the shading, so be careful, because some students say, well, whichever way it's pointing, that's the way that you shade, which it works in this case, but just be careful, because sometimes what they'll do is they'll switch the x and the number, and then it won't be that way. I look at it like this, is I always test a point. Okay, so I say, look, here's a point that I can test in the equation, and that, of course, is the origin, because zeros are very easy to work with. And in this case, where x is supposed to be greater than 2, I just replaced the x value with 0 from the x value that I'm testing. There is no y value to replace right here. And then see if this gives me a true or false statement. This one right here is false, and since it is false, we would shade the other side of that line. Now, of course, since you'll probably be working with a paper or a pencil, and I know that I have another line coming, I would just do short little lines like this saying, or communicating to me that I would shade this side of the line, but I need the other line and shading before I can shade it completely. So the next one we'll do in red. This one is y is less than or equal to -3. So I find -3 on the y-axis. I'm looking for a solid line, because for this one, we do have equality with that equal sign right there. And then we're doing the same thing. We say, well, y is less than or equal to -3, but I'm going to use the same test point because it's not on that line. And so here, instead of a y, I'm going to use the y value from that ordered pair, which is 0. 0 is less than or equal to 3. Again, I get a false statement. Since it is false, the origin, that means I need to shade below that line. So again, if I just had a pencil or a pen, I would be doing something like this. And then I can see that the two shaded areas are in this, I don't know, quadrant, I guess. And then you can use your line or your pencil or pen to fill in that gap as well. Okay. Now, if I was grading exams, I would look at this and see that you have shaded these sides of the lines, but I can clearly see that you've shaded this area as the solutions for this system. So by putting it in like this, we're in good shape, and that's all we really need for this one. No slope. In this one, I guess y has a slope of 0. X equations like this have an undefined slope, which is why it's straight up and down like this. But that's the way I would do this type of problem. Hopefully that helps. We'll see you guys later.